Hi, Stuart Sumner here, week 2 interactive presentation, and we are building a do-it-yourself lava lamp, which is pretty cool. The lava lamp works through two different scientific principles, density and polarity. So let's get into the experiment here. We're going to build it. We need a empty bottle here, and we need some water and some vegetable oil, and then I'm going to use some red food coloring to make it red lava. Plus, we're going to use Alka-Seltzer. Now, normal lava lamps use heat, but the Alka-Seltzer is going to replace the heat from the light. So, what we're going to do here is pour a little bit of water into the bottom, and then we're going to fill the majority of it with oil. Now, there's a little bit of soap still left in here, so that's screwing up the experiment a little bit, but it should still work, hopefully. So what we have now is an oil and water separation. Because the water is more dense than the oil, it stays on the bottom. So we have a separation of the two liquids. And, put some red food coloring in here. Maybe a bit more. So, because the water is denser than the oil, it's on the bottom. But the food coloring is eventually going to make its way down into the water. And the water molecules are polar, meaning their hydrogens are positively charged and the oxygen is negatively charged. And the positive end of water is going to connect with the negative end of other molecules. And the oil is nonpolar, so there's no charge there. So what happens in real lava lamps is that they use liquids that are polar and nonpolar, and the denser liquid sinks to the bottom. But as the light of the lamp heats up the liquid, it makes it less dense and it causes it to rise up to the top. But as it rises further to the top, it gets away from the heat and it cools down a little bit, so it becomes more dense, and then that causes it to sink back down, and then it just cycles through there. So what we're going to use here in this experiment is a packet of Alka-Seltzer. So when we put this tablet in here, the Alka-Seltzer is going to add carbon dioxide to the water molecules and make it become less dense than the oil, which is going to make it rise up. As you can see here, it's creating a lava lamp type reaction. That's pretty cool. I've never done this before. So when the Alka-Seltzer is all used up, then the water and oil should separate back again. I'm not sure what the foam on top is. Like a byproduct, that could be the soap that's still left in there. Let's put some more in. But once that carbon dioxide and the water reach the top, and then the gas bubbles pop, that's when the water molecules that are colored sink back down to once again separate from the oil because they're more dense. So they're only less dense for a while until they reach the top, and then the carbon dioxide is given off and popped, and then they fall back down and re-separate from the oil. So that's pretty cool. I've never done that experiment before. It worked out well, and it's a pretty easy experiment, and it's a pretty neat thing to do for like kids, to show them different densities and how liquids separate themselves. So thank you till week 3. We'll see you later.